Hi everyone, my name is Nitish and today we are going to discuss the third question of this series, which is how can we find the intersection node of two linked lists. So without wasting any time, let's get started. The problem statement is we are given with two linked lists with two different head pointers. Now we need to find the intersection node of those two linked lists. For example, in these linked lists, we are having three nodes in common. So the starting of those three nodes will be our intersection point. But if you look at this example, in this, we are not having any node in common. So we can say that these two linked lists do not intersect at any position. Hence, we need to detect whether or not those two linked lists intersect any point or not. In case yes, then we have to return the intersection node. I hope you guys are clear with the problem statement. Now let's get to the solution part. To find the solution of this problem, first let's try to understand what we need to implement. So we are given with two head pointers of two different linked lists. And what we need to do is we need to find first in common node of these two linked lists. That will be our intersection point. To find the first in common node, what we will do is first we will calculate the length of the first linked list. Let's suppose it is L1. So the value of the L1 will be the value 6, which is length of first linked list. Similarly, we'll calculate L2, which is the length of second linked list, and its value will come out as 5. Once we have both of the lengths, we will calculate the absolute difference of both of the lengths. So the difference will be absolute difference of L1 and L2, that is 1. So once we calculate the absolute difference, we will move the head pointer of the larger linked list by this difference. In our case, the larger linked list is linked list 1. So we will move head 1 by one step. So once we will move head 1 by one step, head 1 will come here. So head 1 will start pointing to this node. So by doing so, what we have done is we have made the length of both of the linked list equal. Now we will start traversing both of the heads simultaneously till we reach at the intersection point. So this will look like something this, while head 1 is not equal to null and head 2 is not equal to null. First we will compare is head 1 equal to head 2. If head 1 is equal to head 2, if yes, we will return that no. If not, then we will move both of the heads one step ahead. Head 1 is equal to head 1 next, and similarly we will move head 2. In case we come out of this loop, that means head 1 or head 2 have reached to the null. So we can say that there is no intersection point and we can return null. Now let's try applying this logic on our example. First of all, we will compare is head 1 equal to head 2, which is not true because head 1 is pointing to this node having value 2 and head 2 is pointing to this node which is having value 7. So these two heads are pointing to different nodes. So we will make head 1 move by one step, and similarly head 2 will also move by one step. So in the first iteration, head 1 will come here and head 2 will come here. Now we will again compare is head 1 equal to head 2, which is not true. So head 1 will move by one step and it will come here. This is our second iteration. And in the same iteration, head 2 will also move by one step and it will also come here. Now we will compare is head 1 equal to head 2, which is true, hence we will return this node, which will be our solution. I hope you guys are clear with the implementation part. Now let's talk about the time complexity and the space complexity of this algorithm. The space complexity of this algorithm will be constant, so can be taken as O of 1. And to find the time complexity, we can reiterate over what we did. First, we calculated this length, and then we calculated the length of linked list 2. Then we move one of the heads by the difference of the lengths, and then we started moving both of the heads simultaneously. So the overall complexity of this solution will be O of n, where n is the number of nodes of the larger linked list. I hope you guys are clear with the algorithm. Now let's look at the code for this solution.
First, we will check if any of the heads is null, then we'll simply return null because the intersection node cannot exist. We will calculate the length of linked list A. Similarly, we will calculate the length of linked list B. Then we will find the absolute difference of both of the lengths. If the length of linked list A is greater than the length of linked list B, then we will start moving head of A ahead till the length of both of the linked list become equal. In case the length of linked list B is greater than the length of linked list A, then we will start moving head of B ahead. Then we will start traversing both of the linked list simultaneously. If the head A and head B are equal, then that means we have reached at the intersection point. Hence, we will return that node. In case head A and head B are not equal, then we will move head A by one step and also we will move head B by one step. In case we are coming out of this loop, that means intersection point does not exist. Hence, we will return null.
If you guys enjoyed watching this video, please like and share this video. And also do not forget to subscribe to my channel. I see you guys in the next video with a new problem.